So what we want to look at now is we want to look at solving polynomial inequalities. So this is very similar to what we were doing before when we were like finding the zeros of a polynomial function. We're just kind of adding some extra steps to it. So what I have here is I have an example in which I want to solve this inequality. So the big thing is that you want one side to be with 0. We want one side 0 on one side, okay? Side of the inequality. Okay, that's the big thing. That's the first thing we want to do. Okay? And then what we're going to do is do almost exactly the same thing that we did when we were trying to find the zeros of a polynomial function. Okay? So what do we do first? Well, step one is we want to figure out the factors of the constant term and factors of the leading coefficients. So in this case, I'm looking, my constant term is -6, and my leading coefficient is 3. So I'm going to figure out all those factors of -6 and all the factors of +3. That's the first thing I'm going to do. So I write those all down. Okay? The second step is to take all the factors of the constant over the leading coefficient. And what we're going to do is we're setting up to plug these in to this inequality. Okay? So like I take 1 over 1, 1 over 3, 2 over 1, 2 over 3, 3 over 1. I don't have to take 3 over 3 because that's already 1. And then 6 over 1, and I don't have to do 6 over 3 because that's 2. All right? So I have all these possibilities. Okay? My hope is that I don't have to plug all these in order to find one polynomial or find one zero. So what we're going to do is step 3, substitute potential zeros into the equation until you find a factor. And remember, based off the factor theorem, it's a factor if it makes it 0. If this side becomes 0, that's what we're looking for. We want this side to become 0 because that means it's a factor. Like if I plug 1 in, I get -20. So I get -20. So when I plug 1 in, that means x minus 1 is not a factor. Okay? So if I plug -1 in, I get 0. So what that means is that x plus 1 is a factor. So before I go on and plug the rest of these in, I want to make my life easier and try to make my polynomial smaller. So what I'm going to do is step 4, I'm going to plug, once I've identified a 0, use synthetic division with that 0. So I know that x plus 1 goes into this quantity perfectly. So what I want to do is I want to divide this whole polynomial by x plus 1 by plugging -1 into this. So I'm going to bring down the 3. I want to do -4. I'm going to do -13 and -6. So I'm going to bring down the 1, or bring down the 3. Multiply -1 times 3 to get -3. -4 plus -3 is -7. -1 times -7 is +7, which gets me -6, which gets me +6, which gets me 0. So I know right now that factored out, this is x plus 1 times 3x squared minus 7x minus 6. Okay? So, I'm here, and the next step is I want to check to see if it's factorable. I want to check, is 3x squared minus 7x minus 6 factorable? Okay? I already know that if I take 3x squared minus 7x minus 6 times x plus 1, I'm going to get this quantity. So is this factorable? And we'll check to see if it is. I know that this is going to have to be a 3x if it is. And I know it's going to have to be a 1x. So if I make this a -3 and a +2, what do I get? I get 3x squared minus 9x plus 2x minus 6. So that does check out. So my fully factored out form is 3x plus 2, x minus 3, x plus 1. So my zeros are negative 2/3, positive 3, and negative 1. Now I'm going to add some other steps. This is kind of where we started before. We wanted to find the zeros, which we did. Well, now we want to solve the inequality. So what am I going to do next? Is I'm going to make a number line with those zeros. Okay? So I know negative 1, negative 2/3, and then positive 3 are my zeros. Mark your solutions on the number line with closed circles if it makes the inequality true. Like if I plug negative 1 into this inequality, I get 0 on one side. Is that less than or equal to 0? Yes. So that means that this is a solution to my inequality, so I'm going to put a 0 there. If I plug negative 2/3 into here, I know that that's going to get me 0. Is 0 less than or equal to 0? Yes. So I'm going to put a closed circle there. And then I'm going to plug 3 in. When I plug 3 in, I get 0 is less than or equal to 0, so that's a solution. Now this is the next thing. Or open circles if it does not make it true. Like if these were just less than or greater than, those are not true, so I'm going to put an open circle for those solutions. Now step 7 is that once I have identified what those zeros are, what I'm going to do is choose values on either side. Okay? Like I'm going to plug negative 2 into this, because negative 2 is on this side of negative 1. I'm going to plug negative 3/4 is a value that's between negative 1 and negative 2/3. A value between negative 2/3 and 3 is 0. I like 0 because it's easy to work with. And then I'm going to plug in positive 4. So when I plug negative 2 into this inequality, I get negative 20, and is that less than or equal to 0? Yes, that is the solution. And if it is a solution, then I know that this side, anything on this side, is a solution. So that means that any value on this side of negative 1 is a solution. Okay? So like I can plug negative 10 in, and if I plug negative 10 in, it's going to make this inequality true. Now, when I plug negative 3/4 in, I get 0.23, approximately 0.23. Is that less than or equal to 0? No. So that means no value between negative 1 and negative 2/3 is a solution. So when I plug 0 in, I get negative 6. Is negative 6 less than or equal to 0? Yes. So that means that anything between these 2 points are a solution. Anything between negative 2 and 3 will be a solution. Now, when I plug 4 in, I get 70. Is 70 less than or equal to 0? No. So that means nothing on this side is a solution. Once I'm done, I'm going to write out an inequality that makes this inequality true. So I know that x is smaller than or equal to negative 1. That's this part right here. Or I know x is between negative 2/3 and 3. So negative 2/3 is less than or equal to x, which is less than or equal to 3. So this is my solution to this inequality. Okay? I have 2 examples that I want you guys to try to do. At least try the first one, and we will talk about it tomorrow. See you in class.